Cycle 2, Lesson 16. In this lesson, we're going to review some basic trigonometry. We need to be experts at our trigonometry, working with the trig ratios, because we're going to do a lot of extension on that basics. So we really should just make sure that everything is at our fingertips. So going back to what you've learned in grade 10, we know that trigonometry is for working with right triangles. And so SOHCAHTOA is a term that we use. It's an acronym that's just supposed to remind us of the trig ratios. SOHCAHTOA: sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. So we always measure from an angle. This is the angle theta that you can see here. That's just a Greek letter that we often use to represent angles. And we label our sides in the right triangle based on what angle we're measuring from. So this side over here is called the opposite because it's opposite from the angle. Adjacent just means beside the angle. And the hypotenuse is always the side that's across from the right angle. It's always the longest side. So there should be no difficulty in orienting yourself around an angle, no matter which way it's turned, which way it's facing. As long as you know what angle you're looking for, then you should be able to find opposite, adjacent, and hypotenuse. And then the ratios are just the lengths of the different sides compared to each other. So the sine is simply the length of the opposite side over the length of the hypotenuse. The cosine ratio is simply the length of the adjacent side over the length of the hypotenuse. And the tangent ratio is simply the opposite side over the adjacent side. So again, it's just one side length over another side length. Now there's something called reciprocal trig ratios. That's simply reciprocal. It simply means that if we flip it upside down, then that's called the reciprocal. So if we take sine, for example, and flip it upside down, so we got hypotenuse over opposite, we could write that as 1 over sine, and that's called the cosecant. If we flip cosine upside down, now we put the hypotenuse on top and adjacent on the bottom, could write that as 1 over cos. That's called secant. And cotangent is the same thing for tangent. Flip it upside down so that we have adjacent on top and opposite on the bottom. Could be written as 1 over tan. We call that cotangent. So we've seen how we can use our calculators to find these ratios. So when we do it in our calculator, it always spits out these numbers, just these decimal numbers. And so it's easy to forget that these decimal numbers are the results of dividing two different side lengths together. So if I type in something like sine 30 or sine 50 or sine 76 or whatever, different degrees, it's the number that pops out would be the ratio of the well, I guess for sine, it would be the opposite side length over the hypotenuse. And so we can use our calculators to find ratios of sine, cos, and tan, but we can also use them to find cosecant, secant, and cotangent, keeping in mind these connections. If I want to know cosecant, I just do 1 over the sine of something. If I want to know secant, I just do 1 over the cosine. Cotangent, I can type in my calculator as 1 divided by the tan of an angle. So, also a reminder that for most calculators, if we want to find the angle, if we want to work backwards, we would use the second function button, which would give us sine. Usually it's going to be written on our calculator, our buttons on our calculator are going to say something like sine with a -1, cos with a -1. Those are the inverse functions. And if I have a ratio and I use the second function to reach these functions on our calculator, it will tell us what the angle is for a given ratio. So like everything in math, you can do things one direction, but you can also do them backwards. Everything in math can be undone and done in the opposite direction as well. So that's a good thing to keep in mind. So let's go through some examples. Determine the primary and reciprocal trig ratios for the following triangle. Also determine angle A using both primary and secondary trig ratios. All right, so from angle A, or from A is in this corner, so let's call this angle A here. There's your opposite side, as it's already labeled for us. There's the adjacent side. This one's the hypotenuse because it's the one that's across from the right angle. So again, it should be easy enough to label our three sides. Sine, and again, if you're having trouble remembering it, remember SOHCAHTOA. I'll write it again here. Sine is equal to opposite over hypotenuse. That's what the SOH tells me. Sine of the angle, and so angle A, we're going to call this angle, is equal to opposite over hypotenuse. Let's get some color going on here. So I'll color the opposite side green. I'll color the adjacent side blue. I'll color the hypotenuse orange. So sine is equal to opposite over hypotenuse. And the opposite side we saw is 3, and the hypotenuse was 5. So it's sine A is 3 over 5, which a calculator, again, doesn't give us things as fractions. If I was to type some angle in and ask my calculator, it would give it to me as a decimal, which would be 0.6. I don't need to give it as a decimal, but I'm just pointing out that that's how why our calculators are always giving us decimals. It's always taking the fractions and changing them into decimals for us. Cos A is, let me just color these. Cos A is equal to adjacent over hypotenuse, isn't it? So it's going to be 4 over 5 because the adjacent side in this case is 4, the hypotenuse is 5. As a decimal, it would be 0.8. And tan A, tan is equal to opposite over adjacent. So that would be 3 over 4. As a decimal, that would be 0.75. Now, the reciprocal ratios are flipping them upside down. So the reciprocal of sine is cosecant. So cosecant A is going to be 5 over 4. I'm taking this sine, flipping upside down, so not 5 over 4, as I just noticed when I circled it, 5 over 3, because it's just hypotenuse over opposite. So 5 divided by 3 would be 1.6 repeating. Secant is the reciprocal of cosine, so it's going to be 5 over 4. It's going to be the hypotenuse over the adjacent, which would be 1.25 as a decimal. And cotangent is the reciprocal of tangent, so that one would be 4 over 3. 1.3 repeating as a decimal. I could use any one of these to find out what the angle A is. So say I picked sine. If I was to try and find out what angle A is, I could do the inverse sine. So that's that sine of -1 of 0.6 is going to equal angle A. So on my calculator, you can see it's got, I don't have to do second function on this iPad calculator. I set sine -1. Make sure your calculator is set to degrees. You can see mine is set to degrees. I can toggle back and forth between something called radians and degrees, but for this course, we're going to use degrees. So I go sine -1.6, and it tells me that my angle is 36.9 degrees, or let's round to the nearest degree. So it's approximately 37 degrees. I guess maybe I'd rather write it like this. I'll write the angle A over on this side. And then I could say angle A equals 37 degrees. I think that's what it was, wasn't it? 37, just double check that. Yeah, 37 degrees. But that works for any of these. I could pick any of these. So say I did a tan, I won't do all of them. But if I want to find angle A from the tan, all I would do is take the inverse of tan. So that's tan with a negative 1 of 0.75 in this case. And I should get the same angle. Exact same angle, right? It's the same ratio. It's the same it's the same relationship to each other in this triangle. So the angle shouldn't change just because I do a different trig ratio. All right. And that's all we're doing for this lesson. Just a quick reminder of the trig ratios and a brief introduction to the reciprocal trig ratios.